Welcome to Magic Math Stat. Well, you all have been introduced to the number E, which is called actually Euler's number. But do you know where does the E come from and how it is created? When we see exponential or when we hear the word exponential, the first thing comes to our mind is growth. That is in total exponential growth. So E is very much related to growth. Well, E is related to compound growth. You also need to know something to understand that. You need to know the idea of compound interest, how it works, and the formula A equals to P multiplied by 1 plus R by 100 whole to the power n, where P is my initial amount, R is the interest for one time period, and n is the total number of time periods. Well, unfortunately, if you don't know about compound interest, then hit me in the comments. I will definitely make a video about it. Well, I will start with a simple story. Imagine you have 1 rupee or $1 in your bank account, and your bank is a very generous bank which gives you annually 100% interest, which is compounded yearly. So here I am interested to find out what is the total amount after 1 year. Here our initial amount is 1 rupee or $1, so P equals to 1, R equals to 100, and that gives us R by 100 equals to 1. Then we have n equals to 1. Since this is compounded yearly, one time period equals to 1 year, and hence you can see using the previous formula we get A equals to 1 multiplied by 1 plus 1 whole to the power 1, and that is nothing but 2. Now I will change the story a little bit. Well, as previous case, you start with $1. Your bank annually gives you 100% interest. But now the interest is compounded half yearly. Well, our initial amount is 1 rupee or $1, so P equals to 1. That stays same. But now, since the interest is compounded half yearly, that means one time period is made of 6 months. So in a year, we get 2 time periods. So put n equals to 2. Now our rate of interest will also change. That is the R. Because if you look at the story carefully, the annual interest is 100%. But the interest is compounded half yearly. So now the interest for a half of year or 6 months is the half of the annual interest. So R equals to 100 by 2, and that gives us R by 100 equals to half. So putting that into the formula, we get the amount after 1 year, which is A equals to 1 multiplied by 1 plus half whole square, and that gives us 2.25. So the total amount actually increased. Well, let's modify this story a little more. Now the initial amount stays same, $1 or 1 rupee. The annual interest stays same, that is 100%. But now the interest is compounded quarterly. So now one time period is made of 3 months, because 1 year is made of 12 months, and a quarter of the year, which is 1/4 of the year, is made of 3 months. So in this case, we have 4 time periods in a year. So P equals to 1, now N equals to 4, and the R also changes. The interest will be 1/4 of that annual interest, which is 100 by 4, and that gives us R by 100 equals to 1 by 4. Now let's put that in the formula and calculate the total amount after 1 year. Let's see what happens. So now we get A equals to 1 multiplied by 1 plus 1 by 4 whole to the power 4, and the answer we get is 2.44140. You can open your calculator and calculate it. You will get the exact answer. So the total amount increased again. Now I will modify it further. Well, the initial amount again stays same. The annual interest is 100% again, but now the interest is compounded monthly. So one time period is made of 1 month. That means a year will have 12 such time periods. So the P equals to 1, that stays same. now the n becomes 12 and the r also will change. So the annual interest was 100%, which is for 12 months. So for 1 month we get 100 by 12 and that gives us r by 100 equals to 1 by 12. So putting that in the formula, we get the total amount after 1 year is 2.61303. Well, now I will modify the story even further. See what happens. The initial amount stays same, the annual interest stays same, which is 100%, but now the interest is compounded daily. So in 1 year we can find 365 days and here one time period is made of 1 day. So in a year we get 365 time periods. So n equals to 365, p stays same, which is p equals to 1. Now the r will change. So we have annual interest of 100% and in 1 day the interest is r equals to 100 by 365 and that gives us r by 100 equals to 1 by 365. And putting these values in the formula, we get the total amount after 1 year is 2.71456. So in the table you can see again the total amount increased. Now I will again modify the story. Now the annual interest is 100% but the interest is compounded hourly. So let's see what happens. P stays same, which is 1. Now in 1 year there are 365 days and in 1 day there are 24 hours. So in a year we get 365 multiplied by 24 hours. We get n equals to 365 multiplied by 24 time periods. Now following the previous cases, you can understand r equals to 100 by 365 multiplied by 24 and that gives us r by 100 equals to 1 by 365 multiplied by 24. And putting these values in the formula, we get the amount after 1 year 2.71812. Now look at the table. Now you can see in the previous case, the first digit after decimal point was 7. And in this case also, we got 7. So after decimal point, the first digit has been stabilized. Let's see what happens in the next case. Now I will compound the interest every minute. So in a year you get 365 days, in a day you get 24 hours, in an hour you get 60 minutes. So the total number of time periods n equals to 365 multiplied by 24 multiplied by 60. P stays same, which is p equals to 1. Now the r becomes 100 by 365 multiplied by 24 multiplied by 60 and this gives us r by 100 equals to 1 by 365 into 24 into 60. Put these values into the equation and you will get after 1 year the amount becomes 2.71827. Now you can see the value got stabilized up to 2 digit after decimal point. So from the previous stories we can understand that if we compound the interest every 1 by nth of a year, then the formula or the expression becomes a equals to 1 plus 1 by n whole to the power n. And you can understand from the table of this value that as n increases, value of this quantity actually increases. But look at another thing. For the first two cases, the increment was 0.25. For second and third case, the increment got smaller. For third and fourth, the increment got even smaller. And for fourth and fifth, the increment got even smaller. So you get the idea. As n is increasing, the value of a or the expression is increasing. But the rate of increase actually is getting smaller and smaller and smaller. So the expression's value is stabilizing as n gets bigger. And now let's make n infinitely large. So you can understand for infinitely large n, the value of this expression 1 plus 1 by n whole to the power n will be very much stabilized. And Euler named this expression E as n tends to infinity. You must have faced this limit. Limit n tends to infinity, 1 plus 1 by n whole to the power n equals to e. So, e is actually a limiting value of an expression, and since infinity can never be reached, we can't completely calculate the value of e ever, but we can calculate its approximate stabilized value up to some digit after decimal point by making n large enough. In the next video, we will learn how to get the polynomial form of e and e to the power x. So stay tuned for that interesting video. Make sure others get the chance to learn something new by sharing this video. And you can like this video and definitely subscribe to my channel and hit the bell icon for more interesting videos like this. Thanks for watching guys. Thanks for your time. I will meet you in the next video.